Thank you so much. It's awesome to be here. And today we're going to talk about what's going on in your node modules folder. So just to start things off, how many of you have ever opened up node modules and poked around and been amazed at what you found in there? Raise your hand. Yeah. There's a lot of good stuff in there, right? A lot of awesome open source code. But we're going to really dig into some of the downside that comes from using so many packages and share some lessons today. So just to start off, a little bit about my background. So this talk mainly comes from my experience as an open source maintainer. And let me just tell you, 100 packages sounds impressive until you look at the size of them. In NPM, we like to do these 100-line, simple things here. But yeah, this talk comes from, that experience, and then sort of witnessing firsthand the massive growth of the use of open source in the enterprise and in companies, and then, seeing the rise of supply chain attacks coming along with that. So then I moved into security, and then now I'm focused on scaling open source security in organizations through Socket. So what is this talk about? So I've been working on open source full-time since 2014, and I really seen the rise of attacks utilizing open source, and so this talk is basically to share these lessons with you all. But first off, you might be wondering, what is a supply chain attack? And so this term is starting to be mentioned more and more. And so if you haven't heard it, the sort of the internet's definition of it is, it's when a cyber threat actor, sounds cool, infiltrates a software vendor's network and employs malicious code to compromise the software before the vendor sends it to their customers, right? So they get into the software that you're producing at your company before you ship it to your users. And so in the JavaScript context, what this means is an attacker somehow gets their malicious code into your node modules folder, right? And so that's all it is. It's not a complicated concept here. Now, there's many, many ways to do it, and there's a lot of things to talk about, so that's what we're going to get into here. But first, we should really talk about why are so many of these attacks happening now? What has changed in the world that this is becoming such a problem? Really, there's three main shifts in the way that we write software here. The first is a massive increase in the number of third-party dependencies. The way we write software has changed, whether it's using cloud services or no-code services or connecting to APIs or just using much more open source. No one really writes software from scratch anymore. We're depending on so many services, so many dependencies, and so many other organizations to produce our software. We're really standing on the shoulders of giants when we build our apps. And just one data point that gives you a taste for the scale of the interdependence that we have here is, in large organizations, which that means those that have over 1,000 employees, they use an average of 177 SaaS applications, which is just wild. How do you remember that many logins? I guess that's what single sign-on is for. But yeah, it's just a lot of dependencies there. And then when you look at the open source side, 90% of an app's code comes from open source. So gone are the days where developers would copy code snippets from Stack Overflow into your editor, or to reinvent the wheel every single time by writing everything in-house. We use dependencies liberally. And that's actually not, that's not a bad thing. I'm not here to tell you that's a bad thing. I think it's actually great. Open source is super powerful, and it's what enables us to build applications in days or weeks instead of in months or in years. And so this is awesome. But with it comes some risk that we're going to talk about. So just to get again another sense of the scale here, this is just one example. This is the Discord application. How many people have heard of who use Discord? It's an Electron app that you install on your machine, and it's built with JavaScript, and it uses almost 20,000 open source packages. Written by almost 400,000 contributors if you count the Git commits. So almost 400,000 individuals have touched the code in some way. And they come from 206 countries. So it's just, the scale of this is, this is actually kind of cool in a way. This is the power of open source, that so many people could come together who aren't, who don't know each other really, and to produce an application like this. It's pretty awesome. But on the other hand, this should also kind of terrify you in the sense that if one person here, were to, be malicious, what effect could that have? And so, so how did we really get to this point where we design software in this way? That's really the question. And the situation we find ourselves in is that installing an average NPM package actually introduces a trust on 79 additional third-party packages that come in as dependencies, and then those are collectively maintained by 39 maintainers, which means that when you install one package, you're actually now adding 39 individuals that you have to trust to your application on average. So this is a pretty large attack surface. Another way to maybe get a sense for the scale here is this visualization that we created at Socket to show you that this is the Webpack dependency. And what you're seeing here is every gray box is a dependency, and every purple box is a file. And so we're sort of peeling back the layers of each package, opening it up, and looking inside to see there are more packages inside, and there are more files inside each layer. And so you can see it just keeps going. There's a lot of files, and there's a lot of dependencies inside that one dependency that you install. And probably most of you use Webpack as your front-end build tool. So the second reason is that change is happening an order of magnitude faster than it used to. So we've gone from a world of releasing software once a year, which was actually pretty common for a long time, to now doing it, monthly, weekly, usually actually many times per day, right? I mean, a lot of companies will actually just deploy on every push to master or the main branch. And so in this world, there's not really an opportunity to do a thorough security review before releasing software into the world. If you're releasing hundreds of times per day, the security team, if you have one even, can't really be a gatekeeper at your company because it's just too fast. There's too much change happening, right? And so in this culture of fast development, a developer might see this nice dependabot pull request asking to update this dependency, and click merge and deploy it into production a mere day or two after this package was published. And so this is good. Keeping your dependencies up to date helps you to avoid vulnerabilities and keeps you on the latest and greatest version of the software. It's a great thing to do, but on this at the same time it actually opens you up to supply chain attacks a little bit more because you're now putting code into production that was published just a few days ago, and there hasn't been a chance for as many eyeballs to look at that code and to look at the security of it, right? I mean, it was published a couple days ago, so how many people could have looked at it, right? And so this is, and I don't know about you, but I merge many of these per day. Raise your hand if you merge, I don't know, more than 5 of these per day, or let's say per week at least. I spend a large part of my day just going through and clicking merge, 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 and I'm not doing a very thorough review of what code is changing in those PRs. And really, each one of these is actually a new third-party code coming into your organization, into your application, right? So, a lot of organizations struggle with this question. How quickly should you update your dependencies? And if you think about it, this scale from slow to fast, a lot of us 5 years ago. Probably were more on the slow end. Maybe let's say 10 years ago, we're on the slow end. And we've sort of learned as an industry that this is bad because it exposes our apps to known vulnerabilities. And we don't want known vulnerabilities in our apps, so we now often use tools to try to avoid this and to update more quickly. So a lot more organizations are on this side now, on the fast side, but we're now learning this actually exposes us to supply chain attacks because the quicker you update your dependencies, the fewer eyeballs have had a chance to look at that code. To make a virus analogy, you can't benefit from herd immunity if you are the first person to catch the virus. So you need some time for the community to find any issues that are in those packages. And then the third reason why we're seeing such a rise in these attacks is that the cost of attack has become so low that you almost certainly will be attacked. Basically, the reach of these dependencies has become so large that even if your company is not a brand name, just by virtue of using open source, you will be affected in some way by one of these attacks because the scale is so large and because we all use so many dependencies. So just one example here, earlier this year, users of the popular Amazon Cloud Development Kit, or CDK tool, were left stunned when they went to go use it and watched it print all this gibberish onto their console, along with the text, liberty, 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 followed by all this really it was an infinite loop of ASCII characters getting printed out. And I'm not an expert in product or marketing, but this isn't the kind of face that a lot of companies want to put forward, or the experience that they want to deliver to their users, I imagine. So what actually happened here? Well, a few months before this, the maintainer of Colors.js, which is one of the dependencies that package used, decided to, well, actually, he announced to the world that he was going to no longer be supporting corporations with his free work, and then a few months after that proclamation decided to sabotage his package. And it was used by 2.5 million weekly downloaders and 29,000 repositories that are publicly visible, probably more that are private. So yeah, just in a moment like that, you could see it affected an organization like Amazon. And it's not just intentional sabotage, there's also package takeover and hijacking. Last October, this post appeared on a Russian hacking forum where you can see some hacker offering to sell somebody's NPM account for starting bid of $10,000 or a buy it now price of just $20,000 if you want to buy it now. And then 2 weeks later, after this post appeared, a package called UA-parser.js was compromised and 3 malicious versions were published. This is actually what the malware looked like that was published there. You'll notice it's using a pre-install script, which is very, very common technique that attackers use when they take over a package. It also has legitimate uses. So it's kind of one of these features in NPM that is sort of love it or hate it. But most malware does use this, and so it is quite an interesting signal. This quote is from a 2022 paper at a security conference where they found almost 94% of malicious packages used this install script feature because it allows your attack code to basically run as soon as the developer types npm install package name and then enter, right? So it gives them that immediate ability to deliver their malware. So it's not surprising that they like to use that. So this is what the code actually does if you dig into it. It's kind of interesting. It geo-IP locates the user using this service. This is a shell script. And then it looks for a few specific countries, Russia, Ukraine, Belarus, or Kazakhstan. And if the user comes from one of those countries, then it just exits the script. It's hard to know what this means, but I mean, well, you can make some guesses about what this means. Probably the malware author comes from one of these countries or works as part of a group that operates in these countries, because usually malware authors don't like to antagonize their local police forces, police departments. They don't want to get in trouble. And so that's probably what this means. So let's say that you come from another country, so this script is going to keep running. It checks to see if the malware is already running on the machine, and if so, it will exit. But otherwise, it will go download it from this, this totally legitimate-looking URL that I'm sure is very safe to visit, and then it will make it executable and then run it. In this case, you can tell by the arguments that it's actually just a cryptocurrency miner, which is probably not something you want to run, but not as bad as, unfortunately, what happened to the Windows users who ran this script. So this is the Windows version of the malware. And I'll just draw your attention to this section here where it downloads a DLL file and then registers it. And what that does is, on Windows, it actually steals passwords from 100 different programs on the machine by looking at the different config files, as well as all the passwords in the Windows Credential Manager. So the Windows users had it much worse, unfortunately, in this attack. So anyone who installed this package during the window when it was compromised would have been affected, and any software builds done during that time potentially would have been compromised. And anyone who clicked merge on a Dependabot PR would have been affected. So that's kind of this is why we see this headline so often, is because hijacked packages it's too easy to do today. There's too many ways that you can hijack a package. A maintainer could choose a weak password. They could give access to the wrong person because they're overwhelmed and they need help maintaining the package, and so they say yes to the first person who offers to help. They could become malicious, as we already saw. They could be protesting something, or they could just get malware on their computer. So we've talked about sort of two TTPs. This is a term from the security industry that stands for tactics, techniques, and procedures. It's basically just sort of different things attackers can do. And I just wanted to draw your attention to just two more that I think you should know about, because they're pretty prevalent on NPM. So typosquatting, this is a very fast-growing technique that attackers are using. And we run this command so many times per day, npm install something, right? I mean, I do this at least a few times per day. Probably most of you do the same thing. And it's a surprisingly powerful command. You're really taking your life into your hands when you type this command, as I've learned over the last few years. This package, HTTP errors, is actually an awesome package. It has 52 million weekly downloads. It's a great package, awesome software. You should use it. But if you make this typo and run this instead, this is not okay to use. Do not run this. This is a bad idea. This will not end well. Actually, this one's taken down from NPM now, but if you had run this, then you'd be in big trouble. I'm going to use the socket tool that we developed to just show you, to dig into the package contents to see exactly what would have happened in that case. So if you view the package TTP error on socket, you'll see in the source code we're showing you the actual contents of the package. So this is not the GitHub repo. This is the actual package, because those can be different. And if you dig in there, you'll see we're actually calling out exactly what's happening. So it's accessing the system shell, and then it's running this command here. And I don't know if you can see that, but I'll make it bigger for you here. This is not a command you want to run on your computer. Downloading something from a bit.ly URL, making it executable and running it in the middle, and having that command run in the middle of an HTTP library just randomly, that's not that's not a good thing. So this is what a supply chain attack looks like. And then the final one I want to just make sure you know about is dependency confusion. This is closely related to typosquatting. It happens when a company has their own private internal NPM registry, and they publish. If you publish private packages to that, then what can happen is, if you aren't careful and you leave those names that you're registering on the private registry, you leave them available on the public one, then an attacker can come along and register the public name. And then if your tools are not careful, they might get confused and download the public version instead of the private version, because it's the same name on both, right? So if your tools get confused, then they might download the attacker's code. And if you just look through packages that have been removed from NPM to look for likely attacks of this type, you'll actually find a ton. So these are a bunch of packages that you can see that by the names of them that they are meant to conflict with internal package names at these companies. Hopefully none of you see your company up here. If so, come talk to me. But these are just a few that we found. And there's really a bunch, though. And so the advice here is, if you're registering package names and they're private packages, just make sure you've also squatted on the name on the public registry so that nobody can register those names. Or better yet, use an organization a prefix on the package so that nobody can register conflicting names. Yeah, and then if you actually go into these packages, you'll find code like this, which, again, I'm not gonna try to figure out what this is doing, but just that should scare you. That is not something you want to run. This is some seriously obfuscated code. And so anyway, this is just the tip of the iceberg. At Socket, we've been monitoring security incidents in open source packages, and we've seen around 400 of these types of attacks in just the last 30 days. Yeah, it's growing. Now, I don't want to be all doom and gloom. I want to leave you with some actual actionable, helpful advice here. So how can you actually protect your app? What can you do? I just want to sort of start at a high level here without talking about any specific tools and products. Like, when you get a developer adding a dependency, this is what they see, right? This is what the developer sees in GitHub, and this is what their teammates see. And there's really no feedback about what this risk, what risk is being introduced by this dependency. It looks deceptively, benign, right? It's just one line. But the truth is, this is potentially bringing in thousands and thousands of lines of code by hundreds of different developers. But the code reviewer of this pull request would have to painstakingly download each of those packages and review every line of code to figure out what this is doing. And almost none of us are doing this today, right? It's too much work. So this is the way we do things now. And so if you think about how closely should you audit your dependencies, today almost everybody is over here doing basically no audit, right? No kind of investigation about the packages that they're using. And this leaves you vulnerable to supply chain attacks, as we've already discussed. The only upside that it has is it's fast. So it's easy and it's fast, right? Which is great. But yeah. Now what we want to do is get more over to this full audit side. Now, what is a full audit? This is done by very, very, very few organizations. This is like, the biggest companies in the world will have a security team that reviews every line of code of every package. This is something that, like the Googles of the world do. Probably most of our companies can't afford to do this, don't have the time to do this, but this is really the gold standard. This is, if you read every line of code of your app, then you'll really know what it's doing. So this is very safe, but unfortunately, it's very slow and it takes a lot of work to do. And oftentimes, the reason why you're using open source is that you don't want to, read that code. You don't want to understand how it works. You're just trying to solve your problem. So, it doesn't seem fun to open up the node modules folder and do all this reading, right? So what can we do here? Now, what if we use a vulnerability scanner, a CVE scanner? This is what people often think of when they think of, securing open source. So this is a great starting point for security. It's a good baseline. Everybody should probably do this. But the thing is, supply chain attacks can take weeks or months to be discovered. And if they're not discovered yet, then there's going to be no CVE. There's going to be no known vulnerability published. And so, in this culture of fast development that we have, a malicious dependency can be merged and running in production in just a few days after it's published. And this isn't enough time for a known vulnerability to be, to be published and make it into all of our tooling. A 2020 paper at a security conference found that on average, malicious packages remain on NPM for 209 days before they're publicly reported, which is just a really long time. And then another paper in 2021 found 20% of malware persists for over 400 days and have more than 1,000 downloads. So, this is, now these aren't the headline-grabbing ones that have like 20 million downloads. You can see this is more like, there's around 1,000 downloads. So there's quite a long tail of malware that's just in these less popular packages that people haven't found yet, which is why you see this sort of, they persist for like 400 days. But, it's really important to distinguish between the vulnerabilities and supply chain attacks because we have pretty good solutions for vulnerabilities today. Vulnerabilities are accidentally introduced by maintainers, and they're accidents, right? They're sometimes okay to ship into production. I think a lot of us just ignore npm audit output to be honest, right? How many people, when you type npm install, you have 500 vulnerabilities, and you're just like, okay, I don't even see it anymore sometimes, it just blends in. It's like almost like saying, your installation worked, right? Success, 500 vulnerabilities. So, vulnerability, you should fix them, but you can get, a lot of them are low severity, and you can get away with them for some time being in production because, they may not be exploited, they may not be discovered, they may be low impact, right? Supply chain attacks, on the other hand, are intentionally introduced by an attacker. Somebody hijacked a package and they put malware into it. And so you basically never want to install these ever, even once, right? You don't have time to wait to fix this in a week or in a month. You just need to catch it before you install it, right? So they're very different. And so using a vulnerability scanner to try to stop supply chain attacks is like the person who looks for their keys under the streetlight because that's where the light is. And so I think really the security industry is a little bit too obsessed with scanning for known vulnerabilities when it's really just too reactive of an approach to actually stop a supply chain attack. And so what we really want to be doing is working towards a position where we're much more proactively aware of what our dependencies are doing. Using just the CVE scanner is much more close to this no audit side of things than we want to be. So what is the solution? So at Socket, we're focused on open source security, and so this is the examples I'm going to use here, but these principles really apply to all of application security and all of AppSec. And the solution is really giving developers visibility and giving them feedback loops. So right now, it's pretty easy for developers to check for certain things in their packages. And a lot of us do check for these things because we want to do a good job, we want to pick good packages, we don't want to introduce tech debt into our teams. And so what are the things that we look for today? We look for, does the package get the job done, right? Does it work? Does it have the features that I need, right? We look for, hopefully you look for this one, is it open source so you can actually use it in your company? We look for, are the docs good? Does it have a lot of downloads and GitHub stars? Does it have recent commits so it's maintained and I know that I'm not using something that was abandoned 5 years ago? And does it have tests? Maybe you also check if it has types, if you use TypeScript. And so these things are, none of these take more than a couple seconds or maybe a minute to look up, and so a lot of times we do check these things today. But if you're a security-minded developer trying to improve the security of your application, then you really need to look at a different set of things. You need to look at, does the package run a shell script at install time? Does the package have native code? In other words, does it contain an exe file or a binary file that you can't audit the source code of because it's been compiled already and you don't know what's in there? Does it talk to the network? If so, which domains? Does it read your environment variables, your tokens and your secrets? And if so, which ones? Does it contain obfuscated code, right? Does it contain that scary blob that I showed you earlier where you don't even know what it's doing? Does it collect telemetry? Does it phone home how you're using the package? This is actually starting to happen more and more. So all of these things today are not easy for a developer to investigate. They take a lot of time. The status quo is that you have to work very hard to find out this information because this file diff tells the developer and the code reviewer very, very little about the dependency. And so we want to be working toward getting into a position where we can proactively make developers aware of what's going on. And so if you give this visibility to developers, they can actually understand the impact of the changes that they're making. And so I'm going to use Socket as an example here because this is what I work on. This is what the developer sees for event source polyfill, the package I showed earlier. When you look it up on Socket, you can see that this package contains protestware, which if you click on the alert there, you'll actually get more details about what it's doing. And it's very clear that this package has some supply chain risk, given that the score is 50 out of 100 up there at the top. Now, say you forget to check the website, say you forget to check Socket. We also have a bot, a GitHub app, that will push security information to the developer directly in GitHub. So it's much easier to say, oh, this dependency that we're using has this risk. And you can see here it tells you exactly what this package is going to do. This one will actually redirect your visitors to a protest petition site after 15 seconds if their language is set to a certain set of languages. And that doesn't include English. So often you'll test your site, you'll think it works great, and then you'll get reports from your users after using this package that some of them are getting redirected to random URLs. So be careful with this one, by the way. It's still live on NPM today. And this can be really empowering, this kind of information, because it creates a feedback loop where the developer sees the effects of their actions. And so the key idea here is we want to enable teams to be secure by default, to do the right thing by default. We don't want to have security be a gatekeeper. We want to just integrate this information into the developer workflow so developers can be self-sufficient. And so in modern security, we want to empower developers to be part of the security solution. And so CI is a really, really good place to do this because you can use modern dependency analysis tools like Socket or others, and you can audit every dependency change. So if you've been using a dependency for 2 years, and then suddenly, tomorrow it comes out with a new version that needs to read your files, talk to the network, contains obfuscated code, and by the way, a new maintainer was added yesterday. All those signals, all those risk signals can be surfaced to the developer so that they can ask themselves, hey, does this package really need to talk to the network? Does this really make sense? And they can click in and see what exactly is it going to do. What is it going to do when it runs? So we don't want this data to be just given to the security team or buried in some internal dashboard. We want to really bring it into GitHub, into the developer's view, so that they see it as they're working. And with this type of deep analysis, you can get more real-time feedback. Another way to think of this is like it's a speed bump. So if you're about to screw up, this is just asking you, are you really sure you wanted to install that package that has 300 downloads, not the one that has 300 million downloads? That's one letter off. It's sort of like a helpful friend coming in and just trying to get your back, have your back. And so we can really increase our speed. We can keep going fast. We can use all the cool stuff, open source, DevOps, cloud. We can ship quickly, but we can do so safely with visibility and feedback loops if we build this into how we do our development. But we need tooling and automation to do it. So security teams and developers can be on the same team. Both teams, both security and developers that want to ship quality software that's secure. And I think in the new age of DevOps, we can do this with with tools like Socket. So thank you so much for having me.